All right. So, yeah, thank you for joining us. Can we just start with some really easy stuff? Like, if you don't mind introducing yourself, so your name, what your kind of main area is, and the role that you have at Perth Observatory.
Yeah, so my name's Matt Woods and I'm from Perth Observatory. I'm an astronomer and also tour administrator here at the observatory. So I get to do all the fun things like organise the tours apart from school day tours and also look after all the marketing and also look after the media when we have these astronomical events. And I get to go out and not only at the observatory but around WA, show people the night sky through telescopes, and every so often I get to do some research, which is really, really cool to do.
Amazing. In your research, do you have a particular area of interest?
Yeah, it's funny. I fell into occultations. So as growing up as a kid, I was real. Just as I was getting into space and astronomy, I was they'd found the very first planet around another star. So that was my big thing growing up was finding out all the new research about exoplanets. But a couple of years ago, I had a chance to with a friend to go and go up to Shark Bay. A couple of friends to go up to Shark Bay and help the NASA's Lucy mission record two asteroids that the Lucy mission is going to in 2033, called Patroclus and Munalicious, pass in front of a star. And so they brought out a whole bunch of Americans from the Southwest Research Institute. So they were along the highway, and we were a little bit further in with a more scenic view at Eagle Bluff and Whalebone Point, and we recorded these positions. And when the next day when we got back to Geraldton, gave our data and were able to see the shape of the asteroids because everyone sees it slightly at different times. So yeah, it was pretty amazing to do it. So I've now done that a couple of times. So it's really point you've got your GPS timing, so everyone's having the same time, and also the weather's got to play nice with you. So yeah, the last couple of times I've had weather ruin it for me. So, but yeah. But it's interesting because it will be all over Western Australia. So the last one I was in, we are in the middle of nowhere between Mora and Dandurrigan. So yeah.
Amazing. All right, so we've got a pretty significant event happening at the moment. I'm not even going to try and pronounce it because I'm going to get you to. Can you explain what it is and, yeah, more importantly, how we all say it?
Yeah, so at the moment we've got the Eta Aquarids meteor shower occurring each night just between 2:30 and sunrise. And what we're seeing is the crumbs of Comet Halley's tail that's been left over numerous passes. They're burning up in Earth's atmosphere. So when we're talking about crumbs, we're basically talking about ice particles, dust particles. Every so often you might get something like a stone. It's just something that's really annoying when you get caught in your shoe. And these things are going at anywhere around about 66 kilometers per second. So when they hit our atmosphere, the friction just builds up and they end up burning up. And sometimes that they actually get dust trails as well if they're fairly big enough. So every year we go through this remnant of the comet's tail. So it's a little bit like driving down, say, the highway, and you come up to a rain shower. It starts spitting a little bit, and then as you get driving heavy, it gets heavier and heavier to the point where you're in the middle and it's just bucketing down. And then you drive out again. And so we're in the middle of the storm over the last couple of days. So it's one of those things that if you go out around about 4 a.m., just gives the Aquarius constellation time to get high enough. And if you look northeast and just keep your head on a swivel, you'll be able to see meteors every so often. So it's not like it's a rain shower. It's more like you'll see one, and maybe a minute later you might see another one. And so the best time to see these meteor showers are on the peak night because there's more chance of seeing them.
Thank you. I think you've answered a whole bunch of the questions that I've got coming up in one. But do you know how it got its name?
Yeah, so its name is because if you draw a line through all those meteors, uh, the radiant point is next to a star called Eta Aquarii, and so that's where it gets its name from. So with meteor showers, we call them after the constellations, and in this case, if they've got a number of meteor showers in that area, then we will then use the nearest star to us. And so the reason I say to keep a head on a swivel is because these meteors will occur, well, they'll occur above your head, they'll occur to the side. Usually it happens behind my back. Uh, so the really bright ones. And so that's why, but if you draw a line through all these meteors, that radiant point is at that in the Aquarius constellation, right next to that star.
Great. And you mentioned Halley's Comet before. Can you just give people a recap on what that is?
Yeah, so Comet Halley actually produces two meteor showers for us. The Eta Aquarids in through late April through to early May, and then they do the Orionids. They cause the Orionids later in late October. So Comet Halley is this very famous comet. The last time it came into the inner solar system, it was 1986, so I was about a month old. So I've got to wait till 2061 because it's got a 72-year orbit, and it's now heading back into the inner solar system now. It's reached its furthest point December 2023, I think it is. But there was this comet that everyone would see over this 76 period, and it was Edmund Halley who went through the records and just noticed that this every 76 years this comet turned up, and unfortunately it was halfway through when he realized this, so he wasn't actually going to see this comet, but he said you'll be able to see a comet this around this year, and that year came along, and boom, that's it. That was the comet. So it was named Halley's Comet. It's also very famous because it also is in the biotapestry of when William the Conqueror came over and defeated Harold Godwinson to become William the Conqueror. So yeah, it's interesting because over the history of human civilizations, comets have been seen as doom bringers. Many of emperor and kings have lost their kingdom or been severely injured, or something bad has happened to them because of comets in the night sky.
Again, just for a bit of recap for people who might not be familiar with this area, can you sort of take us right back and explain what a meteor is?
Yeah, so there's really three terms for a little pebble, basically in space. So while it's in orbit around the sun, it's called a meteoroid. As soon as it starts entering into our atmosphere, that it becomes a meteor. So that's when it starts to brighten. And the really, really bright ones are called bullets or fireballs. And so the friction builds up on these rocks, and so that causes the rock to heat up, and that's why it glows. And when it actually survives the atmosphere, then it hits the ground and it becomes a meteorite. So when obviously also asteroids can hit the ground but essentially these are the small little pebbles, anywhere from basically specks of dust all the way through to something around about basketball size. By the time it gets down to the atmosphere, something the size of a basketball will probably be the size of a cricket ball.
Thank you for explaining. And how often, yeah, like how common is it that we can actually see them? And what would they look like to the naked eye? And how would you recognize that that's what it is versus, I don't know, a plane, a UFO?
Yeah. So we get hit by about 100 tons of material each year. So the only reason we don't particularly see the really bright ones is just because there's 70% of Earth's surface is actually water. So a lot of these really bright ones do actually occur in places where we just don't have human civilization. But we do have, like, the observatory. We're part of the global meteor network. So we've got 8 cameras up on the main building, actually above my head on the roof. And each night they'll just capture images and all throughout the night, and then it'll go. There's actually computer program software there that goes through and actually looks at each of those frames and registers, yes, that's a comet. Sometimes it does register a plane or a moth. So every so often there's a few false positives. But yeah, it's one of those things. We do get hit quite a lot, and even if you just go out into the country, you'll be amazed at how many times you'll see meteors throughout the night, and they're quite what they'll be is quite long, quick streaks. So planes, they'll take a few minutes to go across the sky. The satellites or space junk will take probably slightly longer, and they can be fainter. You're not, and the space junk can actually blink because if it's tumbling. But meteors are very, very quick. They'll last maybe a second or two. Obviously, if it's a fireball, it can last longer, but that's the ones where they can light up the entire night, the whole sky, if they're really, really super bright.
Yes, that's helpful. Thank you. And exactly, you mentioned this before, but exactly how rare is the Eta Aquarids?
So we go through this each year. There's about 10 meteor showers, and then there's a whole bunch of minor meteor showers. So every year we go through this, but again, there's different factors depend on how good it's going to be. So it seems to get replenished every 60 years or so, and then we also have it's weather the moon phase. The moon's starting to get a little bit further in its moon phase. When beginning of the week it's not in the night sky during from 2:30 onwards, but it's getting closer and closer. So sometimes you do have to deal with light pollution from the moon, particularly when it's a full moon. But there's really major ones like the Perseids in the northern hemisphere, and you can see it in northern West Australia and Northern Territory and northern Queensland. And that's the one where you get peak night. If it's directly above you, the constellation Perseus, you can get 180 meteors per hour. For the southern hemisphere, it's the Geminids in mid-December. But there's ones like the Leonids, where every 33 and a half years it has a meteor storm where it does actually appear to be like it's raining meteors. And there's an astronomer I know called Dave Dickinson, who was in the US Air Force stationed in the UAE when the last meteor storm occurred in 1999, and they went out to the dunes and just sat on the dunes, and he said it was basically like a shower. There was that many meteors, so it can be pretty impressive. I think the next Leonids meteor storm is, somewhere at time in the early 2030s. So hopefully it can't come soon enough, because I missed out. It was I was living in Sydney at the time, and of course clouds ruined the nights. So yeah.
And you said before 4 a.m. So what are kind of the best times, but also days leading forward? Would you recommend for people to have the best chance of seeing it?
Yeah, look, I think the peak's been for at least a day or two. So we'd probably you'd want to go out maybe tomorrow morning or the next morning after that. It is one of those things that city light pollution does affect it, and so if you're in the suburbs, you'll probably just see the odd, one that really streaks, and the Eta Aquarids do have a chance to streak. So you get that really nice bright one. But most of these tend to be very faint or on the faint side. So that's where it's worth getting out of the city and going and even getting a camera and getting it just continuously shooting in that direction. And you'll be amazed at how, you go through your shots and go, oh, I didn't see that one. Oh, I didn't see that one. And you can combine those shots and that's where you get the whole, streak one. So yeah. But it's one of those ones where you just drive out, stop off at a stop area, and just let your eyes adjust for 10, 15 minutes, so you get your night vision, and just get a deck chair and maybe have your favorite warm drink and just sit and watch the amazing night sky because all the best objects are in the southern hemisphere. We might not have a pole star, but we've got all the best objects.
And you mentioned getting out of the city and the suburbs. So obviously we're in the Midwest. So how good are conditions out here versus, I don't know, Perth or other parts of Australia?
Oh, look, yeah, it's really good there. So back in 2017, we did an astronomy night at I think it was the fish place up there, and the skies. That was one of the first times where it was like, wow, this is actually really, really amazing. They turned off all the lights. I'd only been volunteering at the observatory for a couple of years, and we'd only just restarted the off-site visits, and so. It's a lot easier to get out to darker skies in around Geraldton than it is Perth. I've got a friend who's got a property near Cunderdin, and when we go out there, it's super dark, but you can still see the light bump from Perth. It's one of those things. Just make sure you've got good skies to the northeast, and if you miss it, record it for on your calendar for next year. But there's always ones like the Geminids as well, which actually happens at more of a reasonable time from 10 p.m. all the way through to sunrise.
And you mentioned
And it's warmer as well.
yeah,
And it's warmer as well.
yeah, better to stay out in the dark for now. You said before about the Southern Hemisphere as well, and just Australia specifically. I'm wondering if you can explain to people why Australia is such a good place to see this kind of event.
Because we're in the Southern Hemisphere, the way the solar system is angled, we get a much better view of the Milky Way, particularly in the southern hemisphere, during our winter, where we're looking into the Sagittarius arm of the galaxy. That's the Emu in the night sky. So starting at the Coalsack Nebula, that's right next to the Southern Cross. That's the beak and head of the Emu. Through the pointers, you get the neck, and then the central bulge of our galaxy is the body of the Emu, and then down, continuing further on, you've got the leg of the Emu, and so that's a very prominent thing, particularly for people who are astrophotographers. That's one in the Northern Hemisphere. They will want to come down and take photos of that. There's also the Magellatic Cloud. So these are two dwarf galaxies that orbit around our galaxy, and they are only seen in the Southern Hemisphere. And so they were also, in some cultures, they were seen as emu eggs as well here in Australia. And so they're also very prominent when you take photos. But there's objects in the night sky like the Carina Nebula, which has the star Eta Carina, which we say it's about to blow at any time. It could have already blown up. We're just waiting for the light to get here. We've got objects like the globular clusters. These are tight balls of around about anywhere between 100 to 170 light years across, where you can get anywhere between hundreds of thousands of stars to something like Omega Centauri, which has 10 million stars tightly packed, and they're really, really old. And you can make them out if you're in dark skies, you can actually see them in the night sky. We've got one of in the Large Magellanic Cloud, there's one of the largest nebulas we've ever seen called the Tarantula Nebula. It's 700 light years across. If you were to bring this to the same distance as the Orion Nebula, which is 1,440 light years away from us, it would take up 60% of our night sky, and you could read a newspaper from it. So, like Texans like to say, everything's big in Texas. Everything's big in the Southern Hemisphere night sky. So,
I can't remember if you mentioned this before, but just do you have a figure of how many will potentially be visible per hour or similar?
yeah. So I've seen rates of about them suggesting rates of about 18 per hour if you're in dark sky locations. That will probably mean if you're in suburbia, you'll probably get maybe at max 5 per hour. So it's one of those things that yes, it might be 4 a.m. in the morning, but if you're getting up early, then you can go up and get the just go out and try and drive out of the city for a bit, and then and have a look at the night sky.
And you mentioned before, just in terms of getting sort of your eyesight adjusted, do you have any tips like that on increasing visibility? Like, how long it might take to adjust or what else you can do just to increase visibility?
Yeah, so really just making sure you turn off off all lights around you, and then just waiting that 10-15 minutes. It is, using a mobile phone is good at the start to find exactly where you need to look. So there's apps like Stellarium and also Sky Safari. They'll actually have night vision mode, so you end up just getting a red screen because red light isn't as harsh. If you are having to walk, particularly at night, yep, use like a head torch. Use the white light to walk to get to your location, and then once you're there, just switch to red light if you do need to use your light because it won't ruin your night vision as much. And then just wait the 10. Just enjoy the night sky as you see as you wait for your eyes to adjust, and particularly around 4 a.m. That's almost within the an hour and a half of sunrise. So you'll start to see satellites, even maybe the space station, Chinese space station, or Hubble go over as well, just depending on when their flyover times are.
Yeah, I'm not sure if I'm going to be getting up at 4 as much as I'm excited.
Yeah, see, like I'm a terrible getter upper in the morning. So if something's at 4 a.m., I'll usually just stay up. So yeah, because there's just been too many times where I've set the alarm and I've either slept through it or I've just looked at it and went, I'm too cozy, and just
Totally,
So
especially with it getting a bit colder. You
yeah.
mentioned you mentioned a few of them coming up, but what's the next big kind of stargazing event that you're most excited about?
The one I'm really excited for is in September 8th, and again, it's not exactly a reasonable time. It starts at 1:09 in the morning, but we'll get a total lunar eclipse. So the partial phase will start 1:09. That will take about an hour. So, and then at about 2:09 in the morning, you'll get the moon will start to turn blood orange and actually decrease in brightness. And that will be for another hour or so. So that's one I'm looking forward to because we didn't get anything here in West Australia for eclipses after the great total solar eclipse up in Exmouth in 2023. So again, I'll be live streaming this total lunar eclipse for time and date. So yeah, looking forward to it.
Might just ask you one more question. Sorry to go backwards,
Yeah,
but because we're on the
that's
topic of
okay.
the moon, just you mentioned it before in terms of affecting visibility. Can you just kind of explain how the moon does affect your ability to see these other events like meteor?
Yeah, so the moon doesn't give off light, it actually just reflects light from the sunlight that it gets. Thankfully, it's not as bright, any brighter than it is. It actually reflects back about 5% of the light that it receives. So you wouldn't want to have something like Jupiter's moon Europa or maybe Enceladus around Saturn, which are just have an ice crust which has oceans underneath them because they would be really, really reflective. But if you go out at night when there's no moon, it is incredibly dark. If you go out now, it will be dark, but we've got a first quarter moon. So you'll notice that you'll be able to see stuff around. You'll easily be able to walk. Or when you have a full moon, all the deep sky objects like nebulas and distant star clusters like globular clusters, they are washed out. They don't look as good. It's a little bit like being in the CBD and trying to see these objects. And so the good time to see the moon is when it's in its first quarter, anywhere around its first quarter and last quarter phase, because you get the terminator line where day becomes night or night becomes day, depending on what's happening. And you can actually see the shadows in the craters on the terminator line, and you get this definition of the crater as well. So it's definitely a good time if you do love the moon. That's a first quarter and last quarter are a good time to have a look. But yeah, full moon is really bad, and it's annoying when you get something like a strong auroras, or you get a meteor shower. That's going to be really good when you've got, say, a last quarter or first quarter, or even a even worse full moon, because it just gets washed out.
Just to confirm, like if we're wanting to, see these meteors or anything like that, we don't need any equipment. We're just going to be able
No,
to
you
see.
don't. No, yep, you don't need any equipment to see these. You just need your eyeballs. Obviously, if you've got a telescope or if you've got binoculars, bring them out there, because you're going to be in relatively dark skies, and it's a good time to just have a look at a few objects. You've got Venus, Saturn, and Mercury up in the early morning sky as well. But yeah, with meteor showers, total lunar eclipses, solar eclipses, aurora. Yeah, you don't even really naked eye comets. You don't need a telescope. Sometimes, well, with a comet, it's best if you want to have a look at the nucleus, the actual comet itself, or you'll probably need a telescope. Binoculars are also fairly good for comets as well. But like the really amazing comets like that we've had, like Comet Lovejoy a few years ago, Comet McNaught in 2006, you didn't need you didn't need a telescope or binoculars to see those. You could easily see them in the night sky.